Hi, welcome back to Moose and Chemistry. Today is pH Problems Lesson 1. We're going to be discussing the hydronium hydroxide ion relationship. First, we need the Kw constant for water, which is Kw equals hydronium ion, which is H3O plus. Sometimes you see it as just H plus. And then you have OH negative equals 1.0 times 10 to the negative 14 molarity squared. Okay, what does that really mean? Well, that means that this is 1.07 times 10 to the negative, not 1.07, growl. Sound like Tigger here, sorry about that. Get talking too fast. Okay, it's 1.0 times 10 to the negative 7m. And the hydroxide ion right there is also 1.0 times 10 to the negative 7. That's why you get m and m give you m squared. And negative 7 and negative 7 give you negative 14. All right, now that we've done the football diagram of this, let's look at this problem. So let me go ahead and erase all this out as much as I can. And we'll be working this problem right away. Just give me one moment. Okay, clear all these stray marks out of there. Okay, so now it says, determine the hydroxide and hydronium ion concentration in a solution that is 1.0 times 10 to the negative 4 molarity HCl. Okay, so you know that since that's the acid, that goes with the hydronium ion, which we told you which was H3O. Okay, so we're going to be looking for the hydroxide concentration. That's that one there. So let's go ahead and erase those arrows real quick. And let's get this down to business. Okay, so now we're going to go Kw equals 1.0 times, whoops, not 4, what's wrong with me? Don't say that, times 10 to the negative 4m, and that's boxed. And this is OH negative equals 1.0 times 10 to the negative 14 m squared. Okay, well, this is going to equal OH minus equals 1.0 times 10 to the negative 14 m squared divided by 1.0 times 10 to the negative 4m. So all you got to do is cancel out one of those m squares, subtract this 4, or add this 4 because it's going to become positive, to that 14 there, and you're going to get 1.0 times 10 to the negative 10 m. And that's that problem. Okay, let's look at another problem. Let's go ahead and erase all this for a second. Okay, so let's look at our second problem. It says determine the hydronium and hydroxide ion concentrations in a solution that is 1.0 times 10 to the negative 3 molarity of nitric acid. Okay, so I'm going to drop the Kw part because we've already shown you that. So we've got H3O positive, and then we have OH negative, equals 1.0 times 10 to the negative 14 m squared. Okay, so we're going to take this number, and we're going to plug it in right there. So let's look at that for a moment. All right, so let's do that. 1.0 times 10 to the negative 3m, box her up there. This gives me OH negative equals 1.0 times 10 to the negative 14m squared. So far, so good. Pretty easy, isn't it? So you take OH negative equals 1.0 times 10 to the negative 14 m squared divided by 1.0 times 10 to the negative third m. So our m's will cancel one each out each. It's going to give me 1.0 times 10 to the negative 11 molarity of HNO3. And that's it for this lesson. Oh, well, you know what? I tell you what, let's see if this really works. Hey, I got an idea. I was going to stop the lesson, but you know what? Let's see. This is our OH, right? So let's plug this back in here and see if we can come up with this. answer. Okay, let's just check it out there. Let's explore. So we're going to go, we'll put it over here, H3O plus OH negative, remember, box it, equals 1.0 times 10 to the negative 14 m squared. So now we're going to go H3O positive times 1.0 times 10 to the negative 11 m gives us our 1.0 times 10 to the negative 14 m squared. So H3O positive is going to be the same as 1.0 times 10 to the negative 14 m squared. Pretty cool, huh? 1.0 times 10 to the negative 11 m. Our m's will cancel out. And lo and behold, we have our answer. H3O positive is equal to 1.0 times 10 to the negative third molarity of HNO3. Hey, that looks like the number that we started with. So yes, it does work. And you guys have an amazing day, and we'll see you back at Moose in Chemistry.